at number 3, you might try reducing down, like that's 15 over 25, right? So Sebastian, how else does that reduce down?
It reduces down
3/5, and do you know your benchmark fraction decimal conversion? What decimal is that? You could probably do a little picture if you didn't, right? 1, 2, 3, 4, 5. That's $1. This is 3/5. What decimal is that?
360.
Right. 60 hundredths, and so that would be 60%, right? Good. So we know that's 60%. So is there anything less than half here that we could get rid of? Or half? Because we already know this is more than half. You know what I'm thinking, Jack? Yeah.
24 points out of 42 is not half, it's less.
24 times 2 is 48.
Oh,
That's okay.
all right.
Bernie?
J.
Jay, 75 out of 150 is 50%. Oh, so that's smaller. Does that make sense? Does everybody know how? Do you guys want to move over there? So I know I try to turn, but I'm sure I forget half the time, right? Is that better? So let's do G just because Jack was looking at that. 24 out of 42. Can you reduce that down, Jack?
Yes. You can divide by 8, right? Or no.
6? Yeah.
6. So for 24 it's 4, and then 42 is 7.
Right. So 4/7. Let's wait on that. That's a lot of hard to say, right? Let's try 75 out of 135. So what goes into those, Jamal? 5. I would go with 5, right? 5 times 15 is 75. Here you might have to do a little long division unless you're super amazing with your math facts in 6th grade. 5 goes into 13 how many times? Twice, right?
3.
Yeah, 35, so 27. What goes into 15 and 27?
3.
Good. Claire, how many times does 3 go into 15?
3 and 9.
Okay. So this is really less. 3, not 3, 5. Yeah. Not okay. Whoops. 5, right? So now we have to compare 5/9 to 4/7. How about we get a common denominator? Okay. What would that be? 63? Right. So this would be 35 out of 63 because I times by 7. This is 9. 36 out of 63. Very close, right? So we're going to get rid of which one? Which one? I didn't hear you. H. I thought you said A. Yeah. So now we have to compare 4/7 and 3/5, don't we? We could do 35. So if we get to 35 here, times by 5, 20. And now we have to do 3/5 times by what? We know it's 60%. Times by 7. Good. That is one of those problems that look so short and easy. It's really deceptive, isn't it? So what's the biggest? F, just barely. That is a great challenging problem. because it makes you go through so many little things. You have to use your fraction skills and, your decimal skills. I wish that they didn't put that first. I should have, now next year, because I'm getting to know the book, I'll say, do that one last. Ellie, you have the next one for me?
I always, well, yeah, but, I spent like half of my day doing.
I know, that's a good, but do you think it helps you when you learn how to do a problem like that?
Mm-hmm.
How many people think that helps them with their skills?
No.
Really? A lot of you do though, right? Because you have to do a lot of thinking.
Well, it helps you with the thinking and working it out, but it doesn't help you in your test if you get it wrong.
Okay, so if that were a test question, it's pretty rough for a test question, but if I had, maybe two things to compare, or even a little bit less, the same idea, this would really prepare you for a lot of test questions, right? I agree. I think it's a little bit much for a test question if there's,
It looks like a teacup.
it's almost, well, there's the thing. So it might be good, but you just have to make sure there's time for it if it were a test question. It's kind of like a whole mini quiz in itself. Ellie.
Oh, I have it.
Excellent. Next one.
So,
This is so much easier, isn't it?
so, yeah, I did 26 out of 60.
Because it's a part to whole, right?
Ratio table, and I multiplied it by 200 because I knew that I'd get 1,200.
Really?
Yeah. And then I divided it by 12, and that's how I got the answer.
Could I just take that a little bit less?
It didn't take as much.
Could we go by 10 instead?
I went by 6, divided by 6. I didn't even use it.
Well, Ellie, only
I didn't even use
because
the ratio table.
isn't that the same kind of idea with smaller numbers?
It helps when it like when
You like the 1200, huh? All right, let's go your way. And then we'll look at maybe one other method.
Grace's method.
So her method is working for her. I would have reduced down. It's so interesting, but it's good to look. It's good to look at different methods. So she multiplied by 200. Really? 20. Did you multiply?
I multiplied it by
But you got 1200, right? You multiplied by 20. So what'd you have here?
well, I just 5,000. Huh?
That just seems hard to believe.
Well, that's not the answer.
What were your numbers? So you had it.
I got worked out 200 and then I divided it by, and then I got 5,000 off, and then I divided it by.
Because 5,000 is bigger than 1,000, right? So how could you have 5,000 on top when you started with a smaller number?
It still worked.
Yeah, so you made a mistake in there.
Well, but it still worked, I guess.
But
She got the same answer.
okay, but here's a good time to stop and think.
But, like,
Time out for a minute.
You got
If your work is wrong, I would have to mark you wrong. Do you know? So I'm trying to point out where your mistake is. Does that make sense? But your idea is right? So let's fix your work. Okay? So you should have only 560 on the top.
well, with the 5,200, when I divided by 12, I got one extra digit, so I knew that since it was
So you adjusted your work. You sort of found your mistake. Okay. Okay. But it's really important to make sure that you know if your work isn't correct, I can't give you full credit because I need to look at your work. So you went to divide by 12, right?
Yeah.
And that gave you 100. So her goal was to get to 100.
Which problem is this?
5. So, and then you must have done a little long division over here, huh? So 12 goes into 56, 12 times 4, 48, right? And then How many times into 40? 3. And do you need to do more? It's a multiple choice, right? So we could have done some other things right away. So what's something else that could have been done, Megan? Oh, you guys look like your arms are gonna pop out of your sockets. And,
I started with 26 and 16 and divided by 6.
okay, hang on to the thought for a minute. Nope, just wait. Before you do a multiple choice problem, always look to see if you could throw something out. What can you throw out, Grace?
Well, I know that 26 is not half of 60.
26 is not half of 60.
And then all the other
Exactly.
are higher than half.
Exactly.
That's what,
So that is really the way to do that problem.
that's
Because it's a multiple choice. Do you guys see that?
yes,
That would have been one where you don't have to show the work.
that's exactly what I did.
Okay, that's okay.
I didn't even show the work because it was.
Because you could tell.
Yeah.
Okay, but Megan, your method, if you didn't see that,
Yeah.
26 to 60,
So,
if you divide it by 6, would still work because you get 10. And here you go, 6 goes into there, right, 4 times. And then you have a remainder of 2, right?
oh, I see right there. And then,
That's 4.3 repeating. So that would have given you this too,
yeah,
quicker.
I also just times by 10 after.
Right. So even though these are both correct, both of these methods, when you're doing a multiple choice, see if you can throw out an answer. Up here, there wasn't a lot to throw out, only this one right here. You still had to do the work. Does that make sense? Okay, those are, good problems for you. Okay, 7. So 7, what fraction of the cats are kittens? Claire?
0.
0?
Because if you, so,
Let me shrink our little table up.
oh no, wait. It's a scale. It says, between 16 and 20, so what you would go by for the 16 and 20 is
Okay, hold on though. We're looking at the totals, right? Remember from yesterday, the totals added up to 100? So we know there's 100 cats altogether, right? And then here are the kittens, right?
Oh,
So what fraction of the cats
I don't know.
are kittens? There's boy kittens and girl kittens, right? Males and females. Fix your answer, what would it be?
I don't know wrong problem.
Okay, but what would it be? Because you can figure it out, right? How many male kittens are there? Total? 17. Boys, males and females. So the 17 out of 100.
You.
What fraction of the cats?
Over. Like the 17 kind of looks like a block over 100.
Oh,
It's okay.
There.
so Lucas, what about the fraction of the cats that are adults?
I said 83%.
That's right. And do you need to look at the chart for that?
No.
No, because it's the other, this is part to whole, and the other part is the 87 left over from the,
No, 83.
83, I mean, left over.
What I did was I just took away 7.
That's what we're saying. You could just subtract, right? Girls in the back, does that make sense? Yeah? Okay, write each fraction as a decimal and a percent. So, Jennifer, how do you write 17 100ths as a fraction and a decimal? Or a decimal and a percent? So just, if you say this with your place value, it's 17 hundredths, because it's 17 out of 100. Can you see? Girls, put your... So, 17 100ths is how you would say the fraction, 17 100ths. So think of it as 10 hundredths, there's 17 hundredths. And then percent is comparing to 100, so compared to 100, 17 per 100. So this would be 17%, which means per 100. So what about the 83 out of 100? What decimal is that? Yeah, and how would you write that as a percent? Yes. So as long as your denominator in your fraction's 100, it's a super easy. Okay? What percent of the cats are kittens and weigh between 16 and 20 pounds? So, let's see, who haven't I heard from yet? We know there's 100 cats. We're looking at kittens. What do we do, Jamal?
Well, it's 0%.
So we're looking for the cats, looking for the kittens. So we're only looking at this column, right?
He's right.
And this column, between 16 and 20 pounds. And the only overlap for 0 and 0, right? 0%.
Yay!
That'd be a gigantic. Yes.
There you go, for like that cat.
Okay. Should we keep going? 15 to 18. Did anybody do 18?
Yes. Yes.
Luke.
For 18, you're supposed to make the. Oh, is it? Did it say 50?
Well, let's reread the problem. Use the following information in a survey: 150 dog owners. So
No, it said.
hold on. Did you read?
It's 200.
And 200 cat owners. So, like, if you put a total in here, there'd be 150, and this is 200.
That's all wrong. I thought it said 50 cat owners.
Okay.
Make a survey.
So we're gonna fix it, right? So they're asked what type of food their pet likes. Does everybody understand? Looks like like if I add up 36 and 116 and 48. Yeah, but 18 still goes with those directions. So 6 and 6 is 12, plus 8 more is 20, carry the 2, 2 and 3 is 5, 6, 4 is 10. So they're telling you the total, okay? And now they're saying, suppose there were 50 cat owners surveyed with similar results. So kind of they all behave, you know, they sort of are like the other 200 people. What do you think when they say estimate? Estimate the counts in each of the 3 food categories. So in other words, if you had human food, if that was 75, if I just look at this as a ratio table,
That's dogs.
45, yes, 30, under the, so this is the human, the pet, and the animals that eat both, you know, like your leftovers at dinner,
That's like my dog.
right?
Don't worry.
And there's a total of 150 here. What do you think it's saying instead of, so like, oh, that's dogs, and I just did cats, huh? I see why you're telling me that. All right, let's try again. Human, pet, both, and the total. This is 36, 116, 48, and 200, they're saying, what if there were only 50 people surveyed?
You'd have to divide by 4.
Do you guys see why she sees that?
I got mixed up and thought you were supposed to times by 50.
No. Okay, so let's think about that. You know, the reason people do surveys is to kind of guess how,
To make stuff better.
you know, like, yeah, like if they survey a bunch of kids to taste, like when my daughter was really little, I remember reading that they were changing the M&M colors. And so they asked kids to, like, see what they like. And then they take in a bunch of kids and they find out what they like. And then because of that behavior, they make certain colors. And so if you survey 200 people, maybe you're a business that makes pet products, right? Then you're going to be able, even though you only ask 200 people, that's still a lot of people. Chances are that the 50 other people in a different place are going to feel the same way. You know, like when you get together with your friends and you all kind of like maybe the same sort of shoes or products, you know, brands, right? And so they're saying, what if there's only 50 people? You know, what do you think these next 50 people are going to think? Are they going to be, what if the next 50 people they ask turn out to be kind of the same opinions?
And it's gonna be
So,
18, like, will be like 28 and H and
I
P
divided it by 2.
16.
I thought you would do it 50%.
I don't know.
so you divide it by 2 for, well, if you divide it by 2, we could get you to the right answer. It's easier, isn't it? This would be 24, this would be 58, 18, but you want to get to 50, so 12, 19, 28, or 29, sorry, and 9. So 9 people have cats that mostly eat human food, so like leftovers, right? 29 people just feed their cats pet food. And then 12 people give them a combination. You guys get that? Yeah. How many people give their pets combination? Right?
My dog eats anything that drops on the floor.
Exactly.
My dog, she eats anything that drops on the floor that's not healthy. My dog's a yeah, like if I have a
Gecko eats crickets. And he won't eat them if they're not alive.
I know. If you put anything that's healthy on the ground, she won't eat it. But yeah, like the other day, I dropped my chameleon left in the shirt.
And my gecko, he also eats mealworms, but if they're dead, he won't eat them. And it's really disgusting.
Cheetos.
Yeah.
Okay, Ellie,
My pet rock
your pet rock doesn't eat anything. Okay. So, all right. Stop, look, and listen. What I like about this book, even though, you know, sometimes it's hard because there's so much reading, is the problems are kind of interesting. You can sort of relate to them. Like, you know, they're sort of real, right? This one. In some cars, the rear seats fold down. There was a picture in your book to go with this. Often there's a 60-40 split. Do you know what that means? Like, the back seat doesn't divide, like some cars the back seat divides in the middle, and then some cars the back seat divides like here.
Yeah.
That's what's together.
Yeah, right? So exactly, this is a part to part, but together it makes a whole, so you need to have, you know, the whole there. If a rear seat is 60 inches wide with a 60-40 split, how wide are the two? So they're saying the whole seat is 60 inches wide.
Oh, I didn't get this.
Look at what they said.
60 inches wide.
If a rear seat, that means this whole seat is 60 inches wide. Each part has to be less than 60, right?
Yeah.
So Seabass, what am I going to do with this? If this is one part, another part, and a whole, how am I going to solve this? What do I need?
35, 60, 40, and divided by 5.
You want to go down by 5? Or half? 30, 20, 50, that was kind of easy, right? Can you do more? By 10s, 3, 2, 5. What am I trying to get to in my whole? So like if you have one of those cards, let me draw a better picture. And it's divided into 60, 6 to 4. So like 6 to 4, right? They're saying that's the ratio, 6 to 4, but they're also saying the whole thing's only 60 inches. So I need to make the whole 60. Can you do that?
You multiply 5 by 12.
Exactly. So if this is 36 and this is 24, what does 36 and 24 add to?
60.
Good job.
10 to 24 ratio.
Well, which is the same as 6 to 4, right? But they're asking how wide are the two parts. So 36 inches and 24 inches. Ellie.
Well, it would be 35 and 25 because
No, because let's 35 to 25. When I divide by 5, I get 7 to 5. It has to be 6 to 4.
it's not 60 to 40. It's still at the
Yeah, but not for this vehicle. Do you get that? There's another split, right? But it's not the split in the problem. What? Go ahead, Ellie.
that looks exactly like my car.
Yeah, the newer cars.
We have a second notebook that's from 2008, and that's like the back, and that's where me and my brother sit, and then there's a number that looks almost exact.
Right. Okay, how are we doing on this, you guys? Should I keep going? Are you getting these? This one wasn't too bad?
I got it. I didn't get this one. This one's
Okay, let me just ask you, like, Jennifer, you remember how you were not sure about percent decimal fraction? Can you go the other way now? What would the decimal be? And so you would just put that, right? And how about the fraction, Jamal? How would you start the fraction? 62 100ths and then reduce if you can reduce. So that's 31 over 50. You can't. Okay. Just because of time, I'm going to come back to this one tomorrow. So I want to give you a little class time. Let's go. So if you're stuck on this one, I know I just heard some of you say it was easy and some of it was hard. Let's just stop and just leave it blank and we'll do a little more on that tomorrow. But what about this? This is a half and this is 3/4 and we're looking for halfway in the middle. Who has the strategy for this? Varney.
What I did was 1/2 of a fourth, or is 2/4.
This is 2/4, right?
And in the middle of that, I don't know if it's correct, but I did 2.5
Okay, so it's mathematically it's the same, but you wouldn't leave your answer like that.
Can I show?
So what could you do next, Jack? So it's a good first step,
This is
right idea.
what I figured out you could do. You can, so if you want to make it smaller, you bring this 4 over and the 1 over, 1 and 4, and it's 1/4. If you want to make it bigger, bring the 2 on top and then the 3 on the bottom. Switch it. See, 2/3.
Oh,
Doesn't that work? Like, you
oh.
bring this down to there, so it's like that, and then you bring the 2 up, so it's like opposite. So the denominator goes up to be the numerator, and you bring down the numerator to be the denominator.
Okay, well, let's see if that's right, or if it's wrong, or if we can make a little more sense of it. Could we maybe go to kind of stick with Barney's idea for a minute and go to eighths? Did anybody go to eighths? What'd you do, Miss Megan?
So what I did, so I knew that I knew eighths and fours kind of like eighths is smaller than fours, so I tried to visualize in my head a full number line, so it was like
Okay,
all 8 jumps and stuff.
okay.
And then I figured that
Well, what's a half in terms of eighths?
it's 4 eighths.
4 eighths. And Lucas, what's 3/4 in terms of eighths?
7 eighths.
Sure. There we go. 6 eighths, right? So what's halfway between 4 and 6? 5 eighths. So, Jack?
Yeah.
That's different than 2/3. Do you see what they did? They just got common denominators until they could find a halfway point. 2/3 is different than 5 eighths.
I know
But it makes sense. 1/2, and then you go bigger, like. It
Well,
looks
let me look at it later.
like
Or,
no, but
not right now, because I want to go to Barney's, which is kind of,
add 1, like
so I'll look at it in a bit. Look, Barney, what you could have done, you could multiply by 10 here, or double. Even easier, probably, you would double. So you could get rid of that decimal. If you double, you get 5 eighths. So after your first step, double to get rid of the decimal. And that'll always work if you're going halfway.
I know what that's called for it.
Oh, well, I meant the fraction.
I know, but I know
What is the decimal?
it's 0.65.
Yeah. Allie?
What I did today, what I do for these columns, is I multiply the denominator by 2,
Yep.
and then I find
Look.
the number.
Yeah. That's what we tried the first time, but we ended up having to multiply by 4. But there's a lot of correct strategies. Did anybody end up getting this? Did you guys figure it out? Zoe, what did you figure out?
It's kind of hard to explain.
Tell me your percentage
Well.
or your fraction. Tell me your
8.
8/10. So that would be 80/100ths. What percent is that? Okay, let's see if it's right. I know we did a little dividing over there, right? You guys started like this, right?
Yeah, we started like that.
And then I drew on it a little bit.
Yeah.
Did you go like this then?
No, it was more like that.
Like this? But not the yellow? Not this one? Did you have little squares or triangles?
It was, well, we started with squares and then we kind of.
Okay. So,
See the paper.
yeah. Because the way I'm going to do it, I think might be different than the way you did it. Okay. I'm going to draw their picture there. Got it. Okay. So, I think it was going to look actually like what I was going to do, but maybe not in the same order. So, if I look at their picture, they had, got it. So let's see. The picture kind of looks like a fish. You see the fish?
Oh yeah.
Okay, but I'm gonna add in a little more because these little pieces, girls, I wonder if you accounted for them. Because you don't have all equal side pieces. Do you see where I just put 2 more lines?
Oh.
Right? So there's a triangle right here. 1, 2, do you see the size?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8 on the left. So how many are on the right?
So it would be
16. And then how many are blue? 1, 2, 3, 4, 5, 6, 7, 8.
8. So 86.
So what percent is that? Or what fraction? Half, right? 50%. Okay, Grace?
I drew it differently.
Yeah, there's lots of ways to draw it. We're gonna run out of time.
I just like flip the.
Could be.
I didn't grab the.
To be exact, it is,
There is simpler.
Yeah, I just flipped the white
So
parts
to be
together and I saw that. And I was
exact,
just
it
oh my
is,
God.
Watch, guys. I know what you guys did.
69.5%.
Look at what. There's some other ideas. No, it's 50%. They took care of got rid of that and chunked it in here, right? Do you see that? And then this part would be gone. Do you get that? And then they took this little triangle here and stuck it in there. Do you see that?
I just like.
And that part's gone.
Whoa.
And then they took this little triangle here
Put it right next to it.
and put it
Like, yeah. Like, I put it down.
down there. So got rid of this and put it in here.
Yeah. And the rest is kind
Oh, and then this one went in here. And so you don't have this.
Yeah.
Yeah, that's yeah. There's so many ways. Okay. Here's the thing, you guys. Give me an honest show of hands. How many people finished every problem from class yesterday and last night's homework? Tell me the truth. All of the class problems
Oh.
and all of these.
Oh.
So I think that you should go back and really understand them tonight instead of throwing more homework in.
Yeah.
But you know you've got a big test next week, right? So if you finished all of them, what I would do is go back to the couple hard ones and spend 20 minutes doing the hard ones. That was yesterday's work, but I know not everybody finished it, right? What I'm saying is tonight I would start studying for your big test by going through last night's and yesterday's, making sure you could do it all.